All right, guys, 2.1.3 is going to talk about solving inequalities. We're going to use some of those same properties that we use for equations in 2.1.2 and 2.1.1 to deal with inequalities. And actually, you'll find, you're going to be a little mad at me, but that's okay. You'll find that this is actually similar to something you've already done. It's very similar to one of the delta maths you already worked with. It's a concept I thought y'all would be good with, and I thought we would blow right through that. We'd be able to blow right through this lesson when we got to Unit 2. But apparently some of us need a little more practice with it, so don't be too mad. You get another chance at it here. So here's some properties of inequality. Again, this chart is going to be in your notes, so make sure you read it or you pause the video and copy it down here and look at these examples and see if they make sense to you, because I'm not going through each one. And then here's your steps for solving it. Really what I want to focus on is this is the part that's different from the inequalities. It's right here. It is important to remember that when you're solving an inequality, the direction of the inequality symbol, less than, greater than, less than or equal to, greater than, it changes when you divide or multiply by a negative. Okay? So here's an example. Your original inequality is 4 is less than 8. Okay? We multiply both sides by 3, we get 12 is less than 24. That's a true statement. We can also divide, and it works the same way. 4 divided by 2 is 2. 8 divided by 2 is 4. 2 is less than 4. That's still a true statement. Okay? However, what happens when we multiply by negative 3? We get negative 12 is less than negative 24. That is not a true statement. Okay? To make it a true statement, we have to flip the inequality symbol. It becomes a greater than symbol instead of a less than symbol. And that actually goes back to this property. I will point out the specific one. That actually goes back to this one right here. If A is greater than B, then negative A is less than B. Okay, if 10 is greater than 6, then negative 10 is less than 6. Because we're changing those signs from positive to negative, we also have to change that symbol. Notice it goes from the greater than symbol to the less than symbol. All right, so just keep that in mind. That's where that comes from. We won't go into too much more depth than that. And now let's look at some examples. Only a couple of examples on this one, not too many. And let's keep going. All right, here we go. So we're going to solve this inequality. All right, only a variable on one side. I'm going to treat this right here just like it's my equal sign. Okay, so we're going to do all our work that way. So to solve this, I need to first realize that my variable is a part of the numerator. And if it's part of the numerator, then the denominator has to be the first thing to go away. Okay, because this is like a grouping symbol. It's like parentheses around that. Okay, it's like that numerator is all grouped together. So we're going to multiply both sides by 7. What that does, 7 divided by 7 goes to 1, leaving us with negative 3x minus 4 is greater than 35. Notice, I multiplied by a positive 7, so there's no need to flip the symbol. Okay. Next, I need to, just like I would an equation, just like I would if there was an equal sign here, that term of 4 needs to go next. I'm going to add 4 to both sides. Okay. Once on each side of the equation. I didn't do plus 4 twice now. Can't do that. Okay, once on the left side, once on the right side. What that does is that goes away. We get negative 3x is greater than 39. Last thing I need to do is to divide by negative 3. I said those words. Divide by negative, right? So go ahead and do it now so you don't forget. The greater than symbol is going to become a less than symbol. It doesn't, the or equal to part doesn't get changed, right? If this was greater than or equal to, then this would become less than or equal to. It's just the direction that the sign is facing that changes. Okay? So divide those out, you get x is less than negative 13. Okay? Now what we should be able to do is plug that back into the original and make sure it works. So negative 3 times negative 13 minus 4 divided by 7 should be greater than 5. Okay? So let's see if that actually works. And what you're going to find is, even though we got a greater than symbol here, this is actually going to make the two things equal. Because what are we saying down here? It had to be some number less than negative 13, right? So if I actually plug in 13, it should make them equal. Okay, so keep that in mind. What I'm saying is it needs to be less than that. So things like negative 14, negative 15, we can't check them all. Okay, but when I do plug it back in, I should get the two things are equal. I'm almost treating it like an equation when I check here. So just keep that in mind, guys. And really you should check, I guess we should check a point above it as well, bigger than that as well. So we'll do that as well, just to make sure. So I get 39 minus 4 divided by 7. is greater than 5. And just like you'd expect, we get 35 divided by 7, and we get 5 is greater than 5, which we know is not true, but like I said, we knew that negative 13, it had to be less than that. All right, so let's try a different one that is actually less than that. So negative 14, right, minus 4. And we're probably not going to get a nice, neat whole number here, but that's okay. I just want to see that it's something bigger than, right? I just want to see that it's something bigger than 5. Okay, so when we do negative 3 times negative 14, we're going to get positive 42. All right, so what I have here is 42 minus 4 divided by 7 is greater than 5. 42 minus 4, that's going to be 38. And 38 divided by 7, doesn't really matter what the exact number is. We know it's bigger than. And it's going to round to 5.43. And that is indeed greater than 5. So when you're testing for inequalities, you want to make sure that you pick a number, right? If you plug in this number exactly, then it's going to be like it's an equation. It's going to make it equal. However, if you plug in a number that is indeed less than that, it should make the original inequality true. So keep that in mind going forward. All right, let's see if we can't get this last one done right here. Same thing as before. We got variables on both sides. We want to get them together. So I am going to add 2x. So that gives me 7x plus 4 is greater than or equal to 11. Subtract 4. And then that gives me 7x is greater than or equal to 7. Divide by 7. And we get x is greater than or equal to 1. So I want to pick a number. I can do 1 and I'll get that it should be equal. So let's do that. 5 times 1 plus 4 is greater than or equal to 11 minus 2 times 1. That's going to be 9 is greater than or equal to 9. Cool. It should also be true if I pick something greater than 1, so like 2. So 5 times 2 should give me a true statement. It's greater than or equal to 11 minus 2 times 2. So that's 10 plus 4, which is 14, is greater than or equal to 11 minus 4, which is 7. So that is also a true statement. Does that make sense? So plug it in, both of them. Okay, and there you go. All right, that's it for that lesson. Good luck with 2.1.3, guys.